I'm doing competition math problems, and this one says the product of three, I almost said positive, had to erase that because that's not in the problem, three integers is 60. What is the least positive sum of the three integers? To give a quick demo, notice that since the integers need not be positive, then we could say -1, -1, 60. That would get us 60, and the sum, this would be a positive sum, 58. So that's one possible number, but we want to try to get the smallest possible. Now, I'm going to approach this by finding the prime decomposition of 60. We can do it pretty fast. It's 6 and 10. 6 turns into 2 times 3. 10 is 5 times 2. Here's the prime decomposition. Now, we want to find some way of picking one, grouping, right? Because we need three factors. So, we're going to have to sort of put these factors together in some grouping of three such that two of them will be negative, one of them will be positive, and the sum will be positive. Let's observe something right, and let's just write out some numbers, right? So I'm just going to write the largest possible value that I can think. I guess I'm just starting with 15. Actually, it's not the largest possible thing I could get, but it seems like a medium size positive part with my two negatives over here. So that would be -4 and -1. And when I take the sum of all of these, I get 10. Now, I do want you to think about what happens if I actually make the factors close together, right? Compare 4 and 1 is about as far apart as I can make these two factors get, and then 2 and 2 is as close as I can make these factors get. So when I do 15, 2, and 2, I get 11, which means that my negative quantity was smaller. Here, my negative quantity, in the sense, like it's smaller in absolute value, this is more negative, leading to a smaller sum. That's worth noting that when you make the factors far apart, they're right. Like, let's just talk about positive factors to think about this a little bit more simply. If you take positive factors and make them as far apart as possible, the sum is going to come out larger. If you make the factors as close to each other as possible, you're going to make the sum as small as possible. So that's just a principle worth noting here. It'll help us to think about things as we go along. Let's now go to the next smallest positive thing that I could possibly create from these, grouping these numbers, which would be 12, because that's, 4 times 3. And then I'll still have to have a factor of 5 and then a factor of 1. There's no other way of doing the factors after that point. And when I compute the sum, I get 6. So I'm doing better, but let's see if we can get even better. Well, we've exhausted what we can do with the positive number being 12, so let's make the positive number 10. Now, again, by making the factors as far apart as possible, I make this sum to the most negative that I can get it to be, and I get this small quantity 3, which is the best so far, and we're really approaching about the best that there could possibly be. Notice that if you did choose factors closer together like 2 and 3, that you wouldn't get quite as small a sum, at the end. Finally, let's set the positive number down to 6, because we can get that from 2 times 3. The remaining factor would have to multiply to 10. We could do it with 10. Ooh, that's supposed to be a -1, but I think you know that. And then, and so now this is a very negative quantity because, 6 minus 11 is going to be -5. And then, now we might actually want these factors to be close together so that we can push the quantity up, actually, because we're too small now. But still, that doesn't even work. And I think at this point, we ought to be convinced that if we can't make 6 work, we can't make any positive number smaller than 6 work. And so we must have found the smallest possible thing, which is 3.